Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Picture this. It's a day of cosmic celebration as NASA's official Voyager account lights up the Twitterverse with news that Voyager 1 is back in the game. After a whopping 5 months of complete chaos and nonsensical messages, NASA finally receives a transmission from interstellar space that actually makes sense. Talk about a triumph in the depths of space. Voyager 1, our intrepid explorer, holds the title of the farthest human-made object from our humble planet, lounging comfortably at a staggering 15 billion miles away. It's been on a grand adventure for almost half a century now, but let's rewind a bit. In the last 5 months, Voyager 1's journey took an unexpected turn. A glitch in the system caused a cascade of confusion, disrupting communication patterns and throwing the spacecraft's history into a whirlwind of stress and uncertainty. But fear not, for NASA's finest minds are on the case. Yet, they face not one, but 2 daunting challenges. Firstly, Voyager 1 is a relic of the past, a testament to the ingenuity of scientists and engineers long gone. Built over 5 decades ago, the spacecraft's inner workings are as mysterious as the depths of space it traverses. The present team must embark on a journey of discovery, delving deep into ancient documents and blueprints to unravel the secrets of Voyager's construction. Secondly, technology has marched forward at breakneck speed since Voyager's inception. While our smartphones boast processing power that would make even the most advanced computers of yesteryear blush, Voyager's onboard computers chug along at a leisurely pace, processing a mere 8,000 instructions per second. It's like comparing a tortoise to a cheetah in a race for the stars. But what of the glitch that plagued Voyager 1 for 5 long months? Why did the tried and true method of turning it off and on again fail to quell the chaos? These questions linger in the minds of NASA's intrepid engineers as they strive to bring Voyager 1 back into the fold of cosmic exploration. And most importantly, has the issue been fully resolved, or does another challenge lie in wait beyond the stars? The Voyager spacecraft, just like our earthly computers, talks to us in a special language called binary. It's all about zeros and ones, which can mean everything from numbers and letters to fancy stuff like pictures or sounds. Voyager 1 has 3 big computers on board, and it turns out that one of them, called the Flight Data System, was causing the glitch. The FDS has an important job. It collects 2 types of info from Voyager. First, there's data from cool scientific gadgets that study space. Then there's info about how Voyager itself is doing, like if all its parts are working right. Once the FDS grabs this info in binary form, it may haze it all together into one big bundle of data. This bundle gets passed over to the second computer, called the Computer Command System. Inside this system is a fancy gadget called the Telemetry Modulation Unit. The TMU takes the bundled up data and turns it into signals that can travel all the way back to Earth. First, it wraps the binary data up in a carrier signal, like putting a letter in an envelope. Then, it sends these signal-wrapped packages through space using something called the Deep Space Network. The DSN is like a big space phone network with giant antennas on Earth, scattered around in places like California, Spain, and Australia. These antennas make sure we can chat with different spacecraft as Earth spins around. So even when Voyager 1 is billions of miles away, we can still keep in touch thanks to this cosmic calling network. After the binary data make their journey back to Earth, they head over to special places called data centers. Here, these binary codes get transformed into something we humans can understand, like numbers, graphs, or pictures. Since Voyager's launch, it's been sharing all sorts of info this way. But things took a strange turn in the last few months. Instead of sending the usual mix of cool space facts and updates on its health, Voyager's TMU started beaming down a bunch of weird ones and zeros. It was like someone was playing a cosmic game of Morse code. Turns out, the FDS wasn't doing its job right. It was sending the TMU some mixed up info, which in turn led to Voyager sending back some really confusing messages. Normally, when something goes wonky like this, the first thing you do is turn it off and on again, right? Well, that's exactly what the team tried. Back in 2010, when Voyager 2 had a similar issue, a quick reboot of the FDS sorted things out. It's like giving your computer a little nap and hoping it wakes up feeling better. This trick even worked for the Hubble Space Telescope once. But this time, the glitch didn't budge, even after a reboot. So NASA's finest had to put their thinking caps on and come up with some smarter solutions. It's like when your usual fixes don't work on a stubborn problem, and you have to dig deeper to find the answer. That's exactly what these brilliant engineers and scientists did to get Voyager back on track. The Voyager team finally cracked the code after months of careful detective work. They pinpointed a faulty chip as the troublemaker behind all their headaches. But how did they uncover this sneaky culprit? Well, in March 2024, they decided to send what's called a poke command to the FDS. Now, a poke command is like a magic spell for computers. It lets you tinker with the values stored in specific spots in a computer's memory. It's kind of like reaching into the guts of the machine and giving it a little tweak. Think of it like this. Remember those old school computers like the Commodore 64? If you wanted to change the text color on one of those babies, you'd use the poke command. You'd punch in a special code like poke 646,7 and boom, your text turns yellow. It's like having a secret code to unlock all sorts of cool tricks. So, by sending this poke command, the Voyager team could dig deep into the FDS's memory and see what was going on inside. It's like shining a flashlight into a dark room and finally spotting the monster hiding in the shadows. And sure enough, they found a faulty chip causing all the chaos. With this discovery, they were one step closer to getting Voyager back on track and exploring the cosmos once again. So, back to our trusty Voyager 1. The poke command gave engineers a nifty way to shake things up in the system's software, hoping to untangle the mess. After what felt like forever, about 22.5 hours later, they finally got a response from the FDS. But here's where things got interesting. Some parts of the system were acting all wonky. It was like trying to read a scrambled message. After some serious brain scratching, the engineers managed to peek into the system's memory and compare it to an earlier snapshot. Lo and behold, they found the culprit. A whopping 3% of the computer's memory was on the fritz. One chip in charge of storing important bits of the FDS's memory and software had called it quits, and no amount of turning the computer on and off could fix it. Now, fast forward to November 2023. With Voyager chilling billions of miles away, fixing that chip was out of the question. So the team got creative. They decided to shuffle around the affected code to a new spot in the FDS's memory. But here's the kicker. There wasn't enough space in one spot for all the code. So they sliced it up into pieces and spread them out across different parts of the FDS. It was like playing cosmic Tetris with code. But that wasn't the end of the story. They had to tweak and tune each piece of code to make sure they played nice together. It was like putting together a jigsaw puzzle blindfolded. The team started with the code that handled the spacecraft's engineering data, moving it to a fresh spot in the FDS's memory on April 18th. Now remember, it takes a whopping 22.5 hours for a signal to travel to Voyager 1 and another 22.5 hours for it to come back. But this time, the wait was worth it. When the team finally heard back from Voyager on April 20th, they got the news they'd been waiting for. Their changes worked. For the first time in 5 months, they could check up on Voyager's health and status. It was like reconnecting with an old friend after ages apart. Voyager 1 was never truly out of reach. It was just like being on a phone call where you couldn't hear the other person. But now, finally, they could hear loud and clear. But wait, there's more to the story. In the weeks ahead, the team will keep on working, shifting, and fine-tuning the rest of the FDS software that got hit by the glitch. Once these tweaks are done, Voyager 1 will be all set to beam back scientific data once again. And let me tell you, this data is super important. See, Voyager 1 is hanging out in a part of space where the sun's influence is pretty weak. It's like exploring a new frontier, telling us all about cosmic rays and magnetic fields in a place we've never been able to study up close before. It's like having a space explorer bring back treasure from the unknown. But as Voyager 1 ventures further into the great unknown, staying in touch becomes a bit of a challenge. Signals take longer to travel, and they lose strength along the way. It's like trying to have a conversation with someone on the other side of the world using 2 tin cans and a string. But despite these obstacles, Voyager 1 keeps on trucking. Now get this, in about 40,000 years, Voyager 1 will swing by a star called Gliese 445. Sounds like a long time, right? Well, in the grand scheme of the cosmos, it's just a blink of an eye. But here's the bitter-sweet part: Voyager 1's days of collecting data are numbered. After nearly half a century of cosmic exploration, its powers are expected to fade out sometime after 2025. Then it'll drift through the Milky Way, silent and alone, possibly forever. But hey, don't lose hope just yet. Scientists are crossing their fingers that Voyager will keep sending back data until its 50th birthday. And speaking of exciting discoveries, did you hear about the James Webb Space Telescope? It just measured how fast the universe is expanding. And let me tell you, the results shook up the world of cosmology. If you missed out on all the action, be sure to catch up and join in on the cosmic excitement. And that's it. Thanks for tuning in to Spaceverse, where we journey through the wonders of the cosmos. Today, we delved into the epic saga of Voyager 1, from its triumphant return to overcoming cosmic glitches. Join us next time as we continue to explore the mysteries of space and uncover the latest discoveries, from distant stars to the very fabric of the universe. Until then, keep your eyes on the stars and your curiosity soaring high. This is Spaceverse signing off.